Hello and welcome. You know, today we're going to talk about the letter R, and I want you to just forget everything you might think about it being this super complex, intimidating programming language. Instead, we're going to see it for what it really is, an amazing toolkit for digging up answers to some really fascinating real-world questions. So let's get into it.
I mean, think about it. We are absolutely swimming in an ocean of data. It's just everywhere. But here's the thing. Data by itself, it's just noise. The real magic happens when you know how to ask the right questions and then actually use that data to find the answers.
Okay, so let's put that idea to the test with a huge question, one with massive global implications. Do countries that are sitting on tons of oil also invest less in green energy? I mean, it sounds like it could be true, right? It's a really complex puzzle, but it's exactly the kind of challenge that data analysis was made for. This question is going to be our guide for this whole explainer. Now, to tackle a question like that, you can't just show up empty-handed. You need the right set of tools. And for thousands of data scientists, researchers, and analysts all over the world, that go-to toolkit is a language called R. So what is R, really? Put simply, it's an open-source language that was built from the ground up specifically for working with data. It gives you this complete environment for, well, everything, from heavy-duty statistical number crunching to creating these beautiful, insightful graphics. Think of it like a master workshop, and inside are all these specialized tools for every single job. Let's look at a couple of the most important ones. First up, there's a package called dplyr. The absolute best way to think about dplyr is as your personal data organizer. Because let's be real, real-world data is almost always a mess. This tool gives you a set of simple, incredibly powerful commands to sort, filter, and basically whip that messy data into a clean, tidy structure that's perfect for analysis.
And okay, once your data is all nice and organized, you've got to tell its story. And that is where ggplot2 comes in. If dplyr is your organizer, then ggplot2 is your data artist. It's built on this really cool idea called the grammar of graphics, which basically lets you build stunning charts layer by layer, turning all those raw numbers into a clear, compelling picture that people can actually understand. So we've got our big question about oil and renewable energy, and we have our key tools. Now let's see how it all comes together in the real world. We're going to walk through the exact kind of workflow a data analyst would use to figure this out. You know, pretty much any data analysis project, whether it's huge or tiny, generally follows these four logical steps. You get the data, you clean it up, you analyze it to find the patterns, and then you visualize the results to share what you found. It's a really straightforward, manageable process. Step 1. Importing the data. Now, for our energy question, we might use a source like the Statistical Review of World Energy. And right away, this is where we hit our first hurdle. Raw data from a spreadsheet is often, well, it's a disaster. It can be full of empty rows, columns with weird names, just all sorts of inconsistent formatting. It's definitely not ready for analysis right out of the box. And that brings us to step 2, cleaning and reshaping. This is where a tool like dplyr is an absolute lifesaver. With just a few simple commands, we can rename those confusing columns to something that actually makes sense. We can filter out entries we don't need, like total world. And then we can reshape the data into a tidy format, where every single row represents one single observation, so one country in 1 year. So after all that prep work, we finally get to the analysis. We use a statistical model to test the relationship, and, well, the results are right here. Now, don't worry about all the numbers. Just focus on the one I've highlighted, the estimate. That negative number, that's our golden insight. It's telling us that for every increase in a country's oil reserves, the model predicts a corresponding decrease in its renewable energy production. Wow. We just used R to turn a messy spreadsheet into a powerful, data-driven answer. But here's the really cool part. R's power isn't just for energy data. That was just one example to get us started. It's an incredibly versatile toolkit that's used to answer questions in, well, pretty much any field you can imagine. So you might be wondering, okay, that's great for economics, but what about other fields? Can you really use the same workflow for something totally different? And the answer is a huge, resounding yes. The same basic principles, clean, analyze, visualize, they're totally universal. Take medicine, for example. Researchers are using highly specialized R packages all the time to do incredibly complex DNA sequence analysis. They're sifting through these massive genetic datasets, just looking for those tiny little patterns that could unlock the next generation of life-saving treatments.
The data's different, but the core process, it's exactly the same.
Or, think about a question that's a bit more down to earth. What's my car actually worth? Analysts use R to dig into these huge data sets of used cars, building models to pinpoint exactly which factors, like the mileage, the age, the brand, have the biggest impact on its resale value. That's how those online calculators can give you an instant estimate.
And in healthcare operations, R can be a genuinely life-saving tool. Analysts study blood transfusion data to understand patterns in donors and recipients. By using R, they can help organizations optimize their supply chains, making sure that critical resources are exactly where they need to be right when they're needed most. So we've seen R answer some really specific questions in a bunch of different fields. But what happens when you scale all of that up? Let's just briefly touch on the kind of complex, high-level analysis that R is powering in super demanding fields like econometrics. I mean, the ceiling for what you can do with R is just incredibly high. We're talking about being the tool of choice for forecasting major economic trends, for rigorously analyzing the real-world impact of a new government policy, and even for trying to model the chaotic ups and downs of the stock market. Now, to do that kind of advanced work, you often need more complex types of data. For instance, a lot of this analysis uses something called panel data. The best way to get this is with an analogy. Standard data is kind of like a photograph. It's a single snapshot of a lot of different subjects at just one point in time. Panel data, on the other hand, is like a video. It tracks the very same subjects over a period of time, which lets you see exactly how they change and evolve. So as we start to wrap up here, what's the one big idea you should take away from all of this? What does R really do for us? Ultimately, R is so much more than just a programming language. It's a bridge. It's the tool that lets us walk from the messy, chaotic shore of raw data all the way to the other side, where we find meaningful stories, clear visualizations, and actual insights that can help us make better decisions. And that really brings us to the most important point of all. The goal isn't just to master the code. The real goal is to learn how to listen. Data always has a story it's trying to tell, and a tool like R is simply the language that helps us hear it. The true skill is in choosing the right methods to let that story come through, loud and clear. So the question I'll leave you with is this: what story is your data trying to tell you? Thanks for tuning in.